what do they want you to do? They want you to calculate the volume of the solid formed when the area enclosed by the curve y is equal to x squared plus 2 on the x-axis from x equals to 0 to x is equal to 3 is rotated through 360 degrees about the x-axis. And they said to leave your answer in terms of pi. This is really the standard way to do it. I'll show you what I mean by that, right? Oh, yeah, I'll show you what I mean by that. So, calculating volume. The minute you see this phrase here, volume of the solid, you know you're dealing with that formula that I just showed you just now. Okay. Volume of a solid is equal to pi by the integral of f of x squared dx with the upper limit being b, lower limit is a. The minute you see volume of a solid, you know that is what you're going to use. That's the formula you're looking at. So you need to determine, like you need to get all the information that you need so that you can use that formula. So what do you need in order to use that formula? Well, you need the equation of the curve, that's your f of x. You need your upper limit, you need your lower limit. Once you have those three things, then you could apply that formula, right? So you do have the equation of the curve. They told you it's y is equal to x squared plus 2. So that's f of x. You also have your limit. They said x is equal to 0 and x is equal to 3. We know b, which is the upper limit, is always the bigger number. So b would be 3 in this case. 0 would be 8 because a is the smaller number, right? And that's all you're doing. Taking that information, using it in the formula that I just showed you for the volume of a solid, and find the volume. Remember your unit. Let's do it now, right? So x squared plus 2, x is equal to 0, x is equal to 3. You just write it. Y is equal to x squared plus 2. They told me x is equal to 0 and x is equal to 3. So I said, once you find volume, all you need to do, apply the rule. V, which is volume, is the integral of f of x squared. So you see, unlike the area where it was just f of x dx, now it's f of x squared. So the equation of the curve squared dx. Your upper limit is still b, your lower limit is still a, and there's something else you need to add in here, pi. So unlike the area where it was just f of x dx, for volume you need to square it, so square the equation of the curve, and you also
But is this
need
the
to
first
make sure
question?
yes, and you also need to include the pi here, right? So like I said, you just use the formula, follow the formula, you're good to go. So I said b would be 3, a is 0, f of x, which is the equation of the curve, in this case is x squared plus 2. So let me just use that information to find my volume. V is equal to pi, the integral f of x is x squared plus 2, so that's x squared plus 2 all squared dx. Upper limit b is 3, lower limit a is 0. From there, all I need to do, apply my rules of definite integration to find my volume. You know the first thing you need to do when using definite integration. So you're just forgetting everything for a little while, everything else except this expression right here. You're focusing on integrating that expression. Same rules you're using, right? Same rules you apply. Just focus on integrating this expression right here. What's the integral of that expression? What's the integral of this?
Would it be x squared plus 1, well, to the 2 plus 1 over 2 plus 1 is x cubed, x to the power 3 over 3. Wait, no. You have to expand the bracket too, sir. Yeah. That's all.
Well, you could, but there's a rule that you could apply here. So instead of expanding the brackets and then integrating, which is a longer way, it's still correct though. You could do it if you want to. There's a rule that you could apply here.
Yeah, I think I remember that rule, but I never understood that rule to be honest. Found it to be funny. Could you go over that rule again, please?
If I'm told to find the integral of an expression that's in the form ax plus b to the n, well, in this case, you really can't apply the rule. Well, that's funny. So let me just show you this thing anyways. Because notice this is x, this is x squared. So yeah, anyways. Ax to the n plus 1 on, what am I doing? Wrong move. That's the rule for this case, if it was in that form. You understand this?
Yes, so because it's with the expanded brackets and we're integrating it. This is the formula that we're using, right?
Yes, you can use this if you don't want to expand and all that. But there's a problem here, right? Look at this formula and then look at this. This says ax plus b. I'm seeing an x squared here. That's the problem. So you have to expand here, right? The rule doesn't really apply because this is an x squared. This is just x. Do you understand that?
No.
No. I can apply this rule. Say I'm given like 2x plus 3. Here, the term is x, just x by itself, right? But here, I have x squared. So technically, I can't really apply this rule here because this is x, and this is x squared. X and x squared, they're two completely different things. Do you understand that?
Yes.
So it would be applicable if I had an expression like 2x plus 3, x and x. But I have x squared. X and x squared are not the same. So yeah, expand the bracket. When I expand these brackets, what would I get? Anybody?
Well, it'll be x squared plus 2 multiplied by x squared plus 2, right? You know, like I do have like my everybody using the distributive law, so x, you multiply each term, so the x squared by x squared, and then x squared by 2, and then 2 by x squared, and then 2 by 2.
So using the distributive law, you can use it. So expand this bracket, and you'll end up with x to the 4 plus 4x squared plus 4.
Really? Could you like expand it out and so I could see it? Because I feel like a little bit and then it'll be like longer.
So you thought what?
Could you like do it bracket by bracket?
So using my distributive law here, plus 2. So we know anything squared is the same as multiplying it by itself, right? So x squared plus 2 by x squared plus 2. The first two by this one, so x squared by x squared, that's going to give me x to the 4. then it's x squared by 2. Well, it's what we put in here, right? So that's plus 2x squared. Then it will be x squared. No, let me x squared, no. 2 by the x squared. So that's plus 2x squared. And then 2 by 2, which will give me plus 4. But these are like terms. 2x squared plus 2x squared is the same as 4x squared. And that's why the final expression is x to the power of 4 plus 4x squared plus 4. You understand that now?
Yes, miss.
Okay. Now I can integrate. I can apply my rules. I see sums, so I can integrate each individual term. So that's what I'm doing now, right? Just using the rules to integrate each individual term.
So wait, right? So because we couldn't use the rule that you stated before is not applicable with the x squared plus the 2 plus the 2, because I looked at it, I felt that you had to expand it to. So now we have it in this form here. Now we have to integrate each part using definite integration, right?
Yeah. Using
Okay.
this expression now I can integrate it. Yeah, let's do that now. So when I integrate this right here, what would I get? Can anybody tell me what I would get? Okay, let me just do it. X to the-
Mr. Mom, I'm eating miss.
Okay. Don't forget your brackets.
Is this the uniform ax n plus 1?
Yes.
Or why isn't that indefinite? Or
No.
no, it's definite integration. The indefinite is with the plus c. My bad. I'm sorry.
That's fine. So when I integrate this expression right here, I'm going to get x to the 5 on 5 plus 4x cubed on 3 plus 4x. Don't forget your brackets, put your 3 and the 0. But because this is volume that we're dealing with, you cannot forget that pi, right? So let me just put like another bracket here. You can't forget the pi. You must include the pi. That's how we find the volume. Cannot forget that pi, okay? So like we were doing before, you substitute the upper limit into hand, the lower limit into hand, subtract the values. You see this pi? We're not really dealing with missing them. See that pi? That doesn't really concern us right now. I'll show you what I mean. So just forgetting the pi for now, right? So let's just pretend it's nothing. You still need it, huh? But just for now, pretend it's nothing. Do what we were doing before. Take the upper limit, substitute it into here. Take the lower limit, substitute it into here. So what would I end up with? 3 to the 5 on 5 plus 4 by 3 cubed on 3 plus 4 by 3. That's my first bracket. The second bracket, do the same thing, right? I don't have space, but you do the same thing, okay? Dot, dot, dot. Like I said, you do the same thing, right? I just don't have space. What we were doing before. Take the 0 and substitute it wherever you see the x. Simplifying this, can anybody tell me what would be the value in this bracket? This value would be 0, right? What's the value for this bracket?
Excuse me, miss.
Yeah.
So in order to find the value for that bracket, you'll have to substitute. Well, oh yeah, we did that, but like basically solve that basically.
So what?
That the bracket, first blue bracket to the left.
What?
Blue. You just like solve it, like put into the calculation,
You mean put the value into the calculator and, you know,
and then
get
solve
a
it.
value? You're kind of breaking up for me. I don't know if it's for everybody else. Kind of breaking up. So can you repeat what you said? Why
Okay,
is
miss,
it
and
here?
like since this is definite integration, we substitute where x was. We substitute where x was, and then we solve, right?
I don't know.
Right?
I don't know what you
Okay,
just
miss,
said.
proceed.
No, I need to hear what you're saying. Can you repeat one more time?
Armis. So basically, I was saying that since it's definite integration, we sub in the value. But like, which one goes first, miss? The top or the bottom?
The top. The bigger
Okay,
number
miss,
goes
I got
first.
you. And the bigger number would be on top, right?
The bigger number what?
The big number would be on top of the bracket, like
Yes,
the
yes.
top of the
The
bracket,
bigger
yeah?
number is always on top.
Thank you, miss.
No problem. So, okay, let me just tell you. Anybody got a value for this? Okay. Well, it's 96 and 3/5. This is where your pi comes in. You see area, it had no pi or anything, but for volume, you have to include your pi. That's where your pi comes in. Give out your answers in terms of pi all the time, right? So I get the value for this bracket, 96 and 3/5. Pi, don't forget the pi, must always include that pi and your unit cube. And this is your answer. You didn't have to put a mix, you could have put an improper fraction. You didn't have to put it like this. But remember the pi and remember the unit cube.
Wait, could you go over this again, please? Like actually work it all sub by sub this full bracket. 96 and 3/5 pi.
Yeah,
So you get a large improper fraction.
yeah. Yeah, you see for volume, these values are gonna start looking kinda weird. You're probably second guessing yourself on things. But you know, that's just life. Gotta do what you have to do. So 3 to the power of 5 is 243 on 5 plus 27 by, yeah, that's 3 and 3. So that's 27 by 4, which is going to give me 108 on 3. Well, that can be reduced. Yep, to 36. 36 plus 4 by 3 is 12. So 36 plus 12, that's 48, right? So let me put it into my calculator. 243 on 243 on 5. So I get 48 and 3/5. And then I know 36 plus 12 is going to give me 48. So that value plus 48. And I get 96 and 3/5. Are you guessing it? Oh, 96.6. Are you guessing the answer? Okay.
Yeah.
Gosh, that sounds so unsure. You sure?
Yeah, once I'm working it, I'll rewrite it and I should get the same answer. It's just I don't have pen and paper right now.
But like I said,
Yes, miss, I
okay,
got it. 96.6.
okay, cool, nice. But like I said, for
Miss, I got
volume,
96.8.
0.8. Ooh, that's a problem. Because 3 on 5 is 0.6. So that's a problem. Did you get this? Like these three values?
Yes, Miss. Miss,
Okay,
probably it's the way I put it in the calculator.
okay. Can you try it again and let me know if you get the 0.6? Like you see area with volume. When it comes to this part and it's simplifying, you need to be extra careful. That's what you put into the calculator and how you put it into the calculator.
I got it now, Miss.
Okay, cool. So like I said, unlike the area, you know, you just get the value and you put your units, unit squared. For volume, it's in terms of pi. So you see this answer right here? It's 96.6 pi. So really, it's supposed to have a pi here, right? We just forget about it for a little while. Get your value, then you include the pi in your final answer. So 96.6 pi, don't forget that pi, and then you put the units. So units cubed or cubic unit, whatever you want to put, right? Just make sure you put the unit. Everybody good?
Yes, Miss.
Yes, miss.
Okay, cool. Your turn.
Wait, could you write the units? Could you write the units?
It's just unit,
96.
units cube or cubic unit. You good? You good?
Yeah.
Okay. Just in case you're unsure what I'm talking about, you actually just write unit cube or cubic unit. That's all you're doing at the end there. So it's 96.6 pi unit cube or 96.6 pi cubic unit. Okay, so that's number one out of the way. Try number two for me. Same thing we're doing. So let's talk it out. And leaving it in terms of pi, right? Just like we did before. So your final answer is supposed to be some value, pi cubic unit, pi unit cube. So they want you to find volume of a solid. The minute you see that, know the formula you're applying is the volume is equal to pi by the integral of f of x squared dx, with your upper limit being b, lower limit is a. The minute you see this expression right here, volume of the solid, you know that's what you're going to apply, right? So what you need to do is find all the information you need to put into that formula so you can get to volume. What do you need? Well, you need the f of x, which is the equation of the curve. You need your upper limit and your lower limit. So remember, upper limit is always the bigger number, lower limit is always the smaller number. So looking at this information that they gave me here, my curve is y is equal to x squared plus 1. So what does that mean for me? F of x is x squared plus 1. And then they told me that x is equal to 0 and x is equal to 1. So the bigger number is b, so b is 1, and then the smaller number is a is 0. Using that information, I have everything I need. So all I need to do is substitute it into my formula and find the value. Try. Anyways, they give you the equation y is equal to x squared plus 1. They told you the boundary of x is equal to 0 and x is equal to 1. I have all the information I need to find the volume of this solid because I know the formula volume is equal to pi by the integral of f of x squared. Let me just tell you now, I know some people write this formula as y squared. So instead of f of x, you might see y squared. It's the same thing, right? Because y is the same as f of x. They both mean the equation of the curve. So whatever the equation of the curve is, right? B, A. Okay. So the equation of the curve is x squared plus 1, b is 1, x is 0. All I'm doing, taking this value, substituting it, find my answer. So this is equal to pi f of x squared plus 1 all squared dx b 1 a 0. From here, it's just apply rules of definite integration and find the value. So you know the first thing you're doing, just forgetting these for a little while, focus on integrating this expression right here. You need to expand the brackets, so on and so forth. Why am I expanding the brackets? Because if it's x squared, the rule that I showed you isn't applicable here because it is x squared instead of just x, right? So you need to expand the bracket, just like we did just now. So what I really have here is b is equal to pi by, my upper limit is 1, so it's 0. When I expand this bracket, I'm going to get x to the 4 plus 2x squared plus 1. Yeah? And now I have the expression in a form that I can actually integrate. Hold on. Why is this chat? Bro, they're still going after. Okay. So now I have it in a form that I can actually integrate. So that's what I'm going to do. I'm finding the integral of this expression right here. What I would get is x to the 5 on 5 plus 2 cubed, well, x cubed, sorry, on 3 plus x. 1, 0, don't forget the pi. The pi is just stay, right, until whenever we're ready to put them back in. Like you're doing before with the area, substitute the upper limit into this, substitute the lower limit into this, subtract the two values. The only difference here is your answer would always be in terms of pi. So whatever value you get after you subtract and all that, just include pi in your answer and put your unit. That's literally the only different thing. Okay, so we substitute in 1 plus. So that's 1 to the 5 on 5 plus 2, 1 cubed on 3 plus 1 minus, you actually write it out, okay? So you're putting the 0 wherever you see x. Just went dot dot dot. Because it'll take a while. But you actually write it, okay? You have to write it. Wherever you see x, put the 0. So this value is going to be 0. So what I'm really focusing on is this. 1 to the power of 5 is going to give me 1, so that's a fifth. Plus 1 cube is 1, so this is 2/3. And then this is plus 1. So what's the value here? It's supposed to end up with 28 on 15. So let me just check that again. 1 on 5 plus 2/3 plus 1. Okay. Are you getting the 28 on 15? Or 1 and 13 on 15? Give me.
Yes, miss.
Okay. But whenever you're dealing with a volume, your answer is in terms of pi. So, okay, yes, this is the value that I got. but I have to include the pi, and then I need to put my unit. So unit Q. And that is it. That's like a 4 or 5 mark question there. It's 3 marks, okay? Don't lose those marks. Everybody good?
Yes, Miss.
Oh, hi, I'm good. Why do you always shout to my class when it's about to end? Like, I think you and Josh planned that thing. That's kind of sucks. Okay, number 3. Let's go. Same thing you're doing, right? Same thing you're doing. Just in this case, yes, you. Just in this case, yeah, you're still finding the volume of the solid, but notice here that it's a straight line, not a curve. But you still applying the same thing, right? Y is the same as f of x. So you see the f of x that you're using would be the x on 2. Your upper and your lower limit, upper would be 6, lower is 0, and just use the rule to find the volume. So I'll wait, and you tell me what answer you get.